Alright, so we're up for an example for finding the absolute maximum. Remember that absolute maximum is the same as global maximum. Just thought I'd throw in a little different vocabulary. Good, so here's my function x cubed divided by x plus 2 on the interval from -1 to 1. And I think I would double check, right, that there's no vertical asymptotes for this problem, because that would give us a little difficulty, right, with maximum. So in this case, our domain for f, right, is x not equal to -2, and so this interval then is inside this domain for where f is continuous, and so we know that f is continuous, so we don't have to worry about vertical asymptotes or anything like that, and we can also use our closed interval method. Okay, the closed interval method says that we look for critical points and endpoints. And so here we go, critical points. F prime of x, remember to use the quotient rule. So derivative of top times the bottom minus the top, derivative of the bottom divided by the bottom function squared. Good, simplifying that a little bit. 3x cubed plus 2x squared minus x cubed divided by x plus 2 squared. Good. By the way, we'll notice that the derivative does not exist at -2, but that's already outside of our domain, so we don't have to include that point. And so just to finish this off, it looks like 2x cubed plus 2x squared divided by x plus 2 squared. Good. And now I want to set that equal to 0, and then factor the numerator. It looks like 2x cubed plus 2x squared equals 0, and take out all the common factors here. 2x squared is a common factor, leaving us with an x plus 1, right? Good, and then x equals 0, 0 minus 1. All right, that's interesting. So we have another -1. That was just a coincidence that -1 was again a critical point, and it just happened to be at our endpoint too. Okay, so now we build a table. That's the second thing we do in the closed interval method. And so on the table we put our endpoints and our critical points. Okay, and then when you plug those into your function, let's see, 0 is an easy one because that's just 0 over 2, so we get a 0. If I plug in 1, I get 1 divided by 3. And then what happens if I put in a -1? Let me clean that up a little bit. If I put in a -1, I get -1 on the top, and then 2 minus 1 on the bottom gives me a 1, so that's a -1 altogether, right? Good, and then we just look for the biggest and the smallest values. Smallest, biggest. Good. And so I think it's really important to write down your conclusion very carefully. So what have we found? The absolute maximum is 1/3. It's the y value, and it occurs at x equals 1. I'll just use quotes here. Oh no, I better write it down. The absolute, I'm getting sloppy myself. Uh-oh. Absolute minimum is -1, and it occurs at x equals -1. Good. And so that's our conclusion right here. And it's always good practice, right, to state your conclusion and use a complete sentence. Good. Let's see. Let me pause for a second. We'll come up with another one. In fact, let's try one with a little bit of trig maybe. It's been a while. Example. This is exercise 40, by the way. Find the critical numbers. for g of theta, I'm going to run out of space, g of theta equals 4 theta minus tangent theta. Remember critical points? Critical points are, or critical numbers, they're the same thing. They are points where the derivative equals 0 or the derivative does not exist. So let's see here. G prime of theta equals 4 minus derivative of tangent secant squared. Right? Set that equal to 0. And that means secant squared of theta equals 4, or cosine squared theta equals 1/4. I'm getting ahead of myself. And so the cosine of theta, is equal to plus or minus 1/2. Good. All right. Let's pause here for a second. All right. So where's the cosine of theta equal to plus or minus 1/2? Well, let's see. Let's see. So if this is theta, and my cosine is adjacent over hypotenuse, that means adjacent over hypotenuse, and that means the length of the third side is the square root of 3. Does this triangle remind you of anything? Hopefully it reminds you of the 30, 60, 90 triangle, or the pi thirds, pi sixths, pi sixths, pi thirds, pi over 2 triangle. Okay, so which angle is this going to be? This is going to be the middle angle, right? The pi 6 or pi thirds. Sorry, 60 degrees, pi thirds. So therefore theta is going to be pi thirds. But then on the unit circle, right, if your x is going to be 1/1/2, then we have one angle here, that's pi over 3. Sorry, pi over 3. But you also have an angle down here that you could have, right? And so that would be minus pi over 3. And then the cosine could also be minus 1/2, so it could be over here instead, right? Or over here. And so what would this angle be? Let's see, pi over 3 plus pi over 3, that'd be 2 pi over 3. Then this would, I guess, would be 4 pi over 3. And then you could say this is 5 pi over 3 instead. It depends on what interval you want to use. Okay, but so these are the 4 solutions that you have between 0 and 2 pi, and then you just add multiples of 2 pi to those. Okay, that's a pi over 3. Good. So you should list as many as you want. Well, not as many as you want, but at least in one complete revolution of the circle. Okay, so are there any other points that we have to be concerned about here? Well, the secant, remember, is 1 over the cosine, and is the secant defined, or let's see, so g prime of theta not defined. Sorry, my clock's going off, does not exist. Where the secant, well, we have to remember secant is 1 over cosine theta, and where is the cosine of theta having problems, or not having problems, or where is it equal to 0? This is 0 to 2 pi, so this would be pi, this would be pi over 2, is that right? 3 pi over 2? I think that is right. So theta equals pi over 2 and 3 pi over 2. Do I have to include these points in my answer? They are points where the derivative does not exist. I could say plus 2 pi, by the way, plus multiples of 2 pi. The answer is no. I don't have to include these. Why is that? That's because these are also not in the domain of the tangent function, right? Because the tangent is sine over cosine. And so these points where the cosine is equal to 0 would not be in the domain of the original function. And so therefore they do not belong, they wouldn't have to be, or you would not say that they are critical numbers. Okay, good. Therefore, the only points we have are these 4 points where we can add pi or 2 pi to those 4 points. Very good. All right. So, boy, that took the entire 10 minutes, huh? uh, we'll do another one in the next example, and it won't be so long.